Alright, so this is part 2 of the lab 2 video. We're going to start with taking the measurement of alkalinity that we started last time by adding sample to our hot kit. We'll go over to our spectrophotometer. Basically, how this works is the reagent in this kit reacts with our sample, and based on how much alkalinity in it, it produces a different color. And this machine calibrates that so that each different color represents a different measurement of alkalinity. So we're going to wipe this down first because this uses a light to measure absorbance, so we don't want any fingerprints or anything on there. So we just put it in the machine. And we get our alkalinity, which is 70.4 milligrams per liter. Alright, next thing we're going to do is we're going to measure hardness of the water. So first step is to measure out 50 milliliters of tap water. So we'll just take that from our sample from earlier. Light metric flask. Remember to measure the meniscus. And there we go. We have 50 milliliters. Add that to our beaker. And just following the procedure from the lab manual, we will actually start by pipetting 1 milliliter of potassium hydroxide, which we will get from the fume hood. Put it here. Here's potassium hydroxide. First I need to adjust the pipette to 1 milliliter, which is 1,000 microliters. There we go. There we go. Next step is to add a indicator pillow, which is basically this packet with the reagent that will react with the EDTA and the calcium in the water. So the way that this titration works is it divides it into measuring the hardness from calcium and then measuring the hardness from magnesium. So I'm going to start with measuring the calcium hardness. So you see it starts out red. We're going to add EDTA until it turns blue. You need to keep track of how much you add, because that will determine how much calcium hardness there is. So make sure to record that. Calcium, so start out at 14.5. So just start adding it dropwise until it turns to blue. again, this is going to happen somewhat suddenly when it does, so just add it slowly, drops at a time. It's starting to turn kind of a purple color on its way to blue. And there we go. So we're down to 17.5. So that means we had 3 milliliters of EDTA added. The multiplier for this is 20 times. So basically 20 times 3, that gives us 60 milligrams per liter of hardness, of calcium hardness as calcium carbonate. And in the world of water, we always normalize hardness and alkalinity as well to calcium carbonate. Just so that we're in the same units. So now we will measure the magnesium hardness. So first we will switch this around. And we will add 1 milliliter of this sulfuric acid. Yep, 1 milliliter of sulfuric acid. Yeah, so we're at 40, so we'll go to 41. All right. And the so we see that the color changed to purple. So now we're going to keep adding sulfuric acid until it goes to light blue and then back to pink. Yep. So see, there's a slight moment where it turned blue. Now it's back to pink. So now we will add 1 milliliter of our hardness buffer solution. And then we will get a different powder packet to add. It reads Manver instead of Calver. So rip this open. Try to. If you make a mistake, if you have trouble ripping, you may need scissors.
Steve, you're better for.
What?
You're better for.
Oh, thank you. So, if magnesium is present, it's going to turn this reddish color. And now we're going to go back to adding EDTA. until the color changes back to blue. So I'll record what our initial amount of EDTA is, which is about 17.5, which is what we had before. And then I will add dropwise until it turns to blue. Turn purple, now blue. Alright. That's about 19.5. So that's 2 milliliters. So again, we applied the same Hawk multiplier. So 2 milliliters times 20 gives us 40 milligrams per liter of calcium carbonate. I would recommend for your lab report, for the discussion, for all of these parameters, you can actually look up the Manhattan water quality report, and you can compare the values that you got to the ones that they're reporting, and see if what you measured is reasonable. And that is the end of today's lab.